lost my side by side. How did that happen? Oh. Keep up to date. Okay. So now what we're going to do is we're going to do the first problem. Okay. So, Gabrielle, look at your worksheet, problem 1. What are they asking you to find? Problem 1 on the worksheet. What's that? Yeah, so CN, true course to steer. Okay, looking at it now, I want you to look at your handout. All right, is that like example 1 or is that like example 2? Is that like example 1 or is that like example 2? Okay, great. It's like example 2. So now what we're going to do is we're going to do this problem. I'm going to do it on the board. And while I'm doing it on the board, we're going to have, I wish that if my tablet was working, I would have done it on a tablet anyway. But now I'm going to do it on the board, and we're going to do it as it was organized in Bowditch. Okay? All right? So first thing I'm going to do, though, what's the first thing I'm always going to do? This is problem 1-1. Okay? So we are, a vessel is from, so let's see here. L1 is 2010 north, and longitude 1 is 122.0 east. And we're going to L2 2618 by 128.20 east. Okay? And they want the course and distance, CN and D. So what's the first thing I'm going to do here? Always. Well, I'm going to do that, but before I get to Bowditch, I'm going to get my mind map. I'm going to do some bulking shit on that thing, okay? I'm going to be like, mind meld on this thing. I'm going to draw a picture. Okay? Bowditch doesn't draw the pictures, but you should be drawing a picture. So let's just draw a picture of what the F is going on here. You can draw this picture a number of different ways, okay? I could draw the picture like this, okay? Where this is the prime meridian and that's the equator, okay? All right, and I like this. You can also draw it as a circle. You can put a circle around there, or you can just draw your navigational triangle. But I like this because it tells me the relationship between particularly east and west longitude. Should I be adding them, subtracting them, whatever it is? Okay, so this is the northern hemisphere, southern hemisphere, eastern hemisphere, western. So where am I in? I'm north and I'm going further north. So I'm going north, okay? And then I'm east and I'm going what east? So there we go. This is what it looks like. Okay? All right, I'm doing that. So I'm going, my navigational triangle, you ready? Is north and then it's east. So, all right, here's C. Here's C. So what's the relationship between CN and C? Quadrantial notation. Okay, now, I'm going to start a new sort of way of kind of writing this down a little bit, okay? The prefix is always north or south, and then it's going to be C, and then it's going to be east and west, east or west. So, what direction did I go? North. So I'm going to, there we go. And then what direction did I go? And then there it is. So when I convert CN to C, I'm going to do north, C, east. Okay? All right? Okay, great. So, what do they give me? Well, all right, so they gave me those things. All right, cool, great. All right, so I got my little picture here, and I'm going to need this at the end. I'm going to need this at the end because I'm going to do a calculation of C, and I'm going to need to convert it to CN. We've been doing this. I'm just coming at it from a slightly different angle. Okay, I think some of you might still be struggling with this, so I'm coming at it from a different angle. Okay, okay, great. All right, cool. Now, Chuck, looking at Bowditch example 2, they have the list first, or do they have some computational stuff first? Well, the list is actually down here, right? So there's computational stuff before the list. So what does that mean? We're going to do computational stuff, okay? So we have to do all of this stuff. We have to do all of this stuff, and then we can plug and chug, okay? So that's what we're going to do now. And we're just going to follow along what Bowditch did. We're just going to stick our numbers in. So what's the first thing we're going to do here? What do they do first? They get L and then what? And then half L and then LM. So now we're going to do that. So L1. So I'm just going to do this now. Now remember, put the big one on the top. So in this case, I'm going to do L2, L1. Okay? All right? Okay? So anyway, so what was L2? Yeah, 2618. And L1 was 2010. Okay, and are we going to add or subtract them? We're going to subtract them, and you should get 608. Okay, 608. Rebecca, did we go north or south? Little L is right here. It's 608. Did we go 608 to the north or 608 to the south? To the north. So what's the sign of little L? It's north. Okay. Even if we were in the southern hemisphere, the sign of little L would be to the north. Okay. Cool. All right. Great. So what's the next step, Dylan? What about it do next? Well, shit. So what are you going to do? Okay. So what's half of 608? 304. Cool. All right. Now, DeLong. What are you going to do to that? You're going to subtract it from this one or add it to this one? Okay, so add it to L1. So let's put, yeah, that's easier. I'm going to say plus L1. What was L1? 2010, right? Oh, God. That's in the wrong spot. 2010. So what is L2? What is LM? 2314. Okay? God, this is just a mess. Oh! We're going to take a break after this and we'll come back and do a different one. Okay, we got about another 10 minutes at the most. Okay? 2314. Okay? By the way, if you're like, you know what, I'm good, I don't need to really, okay, you can just work on the worksheets. Okay? But that doesn't mean I'm not going to ask you questions. All right? So anyway, but if you're good and you're like, you know what, I don't need you to kind of like, I feel like I can follow along about it, go for it, work on a worksheet. Okay? But I think many of you need to kind of follow along with me. Okay? So, all right, so cool. All right, now, lovely. What other computational thing did they do? What other let's see, who haven't I called on yet? Tyler M. Yep. Okay, so we're looking at this thing. Okay? Is this computational or is this list stuff? Well, no, see this? Here's the list. DLO, LM, P, L. See that? Yep. That's the list stuff. What's it before it? Before it is math. Yep. So we're supposed to do, what does that say? It says, do this math, populate this list. This is where you're going to plug and chug. When you get to this list view, you're plugging and chugging. But this is math, computation. See that? So, how much of this have we done? Yeah, is there more to do?
No.
Yeah, we gotta do all this shit. We haven't done this yet. So let's do this. Let's do it. Should we do this? Let's do this. Let's do this. Okay, you set me up. Tyler M. Set me up. So they did the difference between longitude 1 and longitude 2. Now, are we gonna add them? Are we gonna subtract them? What are we gonna do? Okay, so which one are you gonna put first? Longitude 1 or longitude 2? You're gonna put okay, now they put longitude 1 first, but we're gonna put longitude 2 first because longitude 2 is bigger in our problem. Cool. So we're going to go longitude 2, longitude 1. We're going to populate that with our numbers, which in our case, our numbers are, what are our freaking numbers? 128.20. And that was east. And the other one was 122.20. No, 122.0 east. Cool. Damn, think about it. Okay, what next? So now I do a little bit of mathy poo. I'm going to do the math for you, okay? That's 6 degrees, 20 minutes. Okay? Tyler, look up at Bowdish in example 2. Did they leave it at 6 degrees, 20 minutes, or did they do something at 6 degrees, 20 minutes? Damn, they did. Well, if it's good enough for Bowdish, it's good enough for who? Yeah, hell yeah. So how did they go? In their problem, they went from 1408 to somehow or other 898. How did they do that? Well, so you're going to do something to this number right here. Okay? You're going to multiply the 6 degrees times 60, and then you're going to add in the 20 that was remaining. Okay? So what's 6 times that? It should be like 36, 360, and 20 should be 380, I think. Yeah, 380. Okay? 380. Okay? That's tricky. And what direction were we on, Rebecca? East. So what's the sign of it? East. Okay? Now we happen to be in the east hemisphere and we're going further east. If we were in the east hemisphere and we were going in that direction, what would the sign of D-low be? West. Okay? All right, cool. All right, great. Dan, hey, check it out. Dylan, what would you categorize this stuff up here as? Computational or list? Computational. Have we done all the computational? Now what are we into? And the list is play chip. Okay, now, by the way, after we do some of that, we might have to do some more computational. But all right, so we're cooking now. We're cooking now. So now we're ready to do our first formula. Oscar, what's our first formula? For example 2, what's the first formula? Number 1.
P equals D low.
Well, then, hell, let's do it. P equals D low and cosine what? Cosine LM. Okay, what is D low for us? 380. We went to all the trouble to calculate that. Let's use it. And what's the cosine of LM? So what's the mid-latitude? Our mid-latitude was, we have to convert it. Did they convert it up in the problem? They didn't really show you that. That's something you're just going to have to know. I'm going to stick it into a cosine. I have to convert it. Sorry about that. It's not in the list, but it's something we have to do. So how am I going to convert 2314 to its degrees, decimal degrees, to degrees minutes? How am I going to do that? What's that? Well, I'm going to put it into a trig function. So am I going to convert it to minutes or degrees? Degrees. So now you're going to do some division of 60. Okay, but am I going to divide 23 by 60 or 14 by 60? Yes, okay. So if you're going to divide the minutes by 60. If you're going to multiply, you're going to multiply the degrees times 60. So when I do that, LM also equals 23.2333. Okay, now it would have been nice for Bowdish to have stuck that in there for you, but they didn't. You're just going to have to know to do that. Okay, because you should never stick something into a cosine function that's not in degrees, decimal degrees. So it's cosine 23.233. And I'll do the math for you. P equals 349.2. Okay, and we went to the east. Okay, so that's distance. Well, that's not distance. That's not distance. 349.2. Okay, that's P. What's the next formula? tan C. Okay, so now we got tan C equals, what is it? P over L. Okay? So what are we calculating now? Now we're calculating the course. Well, what am I going to do to tan C? What's that?
Would you get 349 from?
I did 380 times the cosine of 23.2333.
Oh.
Okay? And I got 349.2. Okay, so I did that formula. That was the first formula. Now I'm doing the second part. I'm doing the second formula. Okay? So now I'm doing tan C equals P over L. But I got to rearrange this formula. Okay? I got to rearrange this formula. Rebecca, how am I going to rearrange this formula? Because I want to solve for C, but I got to get the tan on the other side. Okay, so C equals tan the minus 1. What was P? Over what? Okay, so, yeah, I got to put in 184 here. Now, the units cancel out. This is unitless, so it's not a problem. Okay? So, what do I get when I do that? The math ends up being 43.5. The math is 43.5. What is the prefix for the 43.5? So now it's north 43.5 east. The northeast thing from before now comes over here. Somebody had a hand up.
Yeah, where did you get the 184 from?
184.
The L in that column?
Yeah, that converts in minutes.
Oh, here?
Yeah.
Yeah. Okay, did they do that up there?
Yeah.
Yeah, they did. Okay, we skipped over that. Yeah, remember, I showed you that before, but, okay. So, we calculated L here, it was 8 degrees, 18 minutes. But when it came down into the list, what did they do to it?
I did something weird. I said the wrong number.
Oh, you did?
Yeah.
Oh, okay. So that's not the right number?
No.
Oh, it's 368.
Yeah. I put it L in.
Oh, sorry about that. This should be 368. Okay? 368. All right? Okay, great. Sorry about that. Change that right there. So, north 43.5 east. North 43.5 east. What's CN? In this quadrant, C equals CN. Because C, this is 43.5, and from north, it's also 43.5. In this quadrant, C and CN are the same. There's nothing to convert. So CN equals 043.5. That's the course. Okay? Maybe you got a little lost in that for a second? Where'd you get lost? So if you're having trouble seeing, it means you need to get closer to the freaking board. Okay?
No, I got it.
Okay, all right. Okay, good. So,
Did you get D yet?
we did not do D. We did not do D yet. How do I know we didn't do D yet? Because I don't have it up here. How do I get D, Patrick?
L over cosine C.
Now I do the third formula. Okay, so what's the third formula? Third formula is D equals, what is it? L secant C? D equals L secant C. Okay? Tyler Hall,
Yes.
you got a secant button on your freaking calculator? So what are you going to do with secant?
It's gonna be,
I don't have a secant button, so what am I going to do?
it's gonna be, divided by.
Yeah.
Cosine.
Yes. So this becomes D equals L divided by cosine C. Damn. Tyler M. What's L? What am I gonna use? I got two different choices for L. Okay, I got L 608 and I got L 384. Which one do you think you're gonna do? I'm trying to get distance. So do I want to use the L with degrees in it? Or do I want to use the L that's just got sort of minutes in it?
The original L, right?
Well, we're going to come back to this L, okay? But what we're going to do is, remember, this is the weird thing about L. It's north and south. It's along a meridian. A meridian is a great circle. What is the relationship between a minute of arc on a great circle, 1 minute, and 1 nautical mile? They're the same. So on a great circle, 1 minute is 1 nautical mile. So if I convert 6 degrees 08 minutes to all minutes, then I'm going to have distance. So what I'm going to do is I'm going to take this and I'm going to multiply it by 60. That's 360. I'm going to add 8. That's 368. That's what that 368 is. Yes?
We're able to say that minute to miles conversion because we're assuming that they would just like continue going around, right? Like,
Well, look, here's what's going on here. What is the function we're doing right now? D equals L over cosine C. Okay? So this has no units. If I want distance, I want it in miles. So I could, if I wanted to, I could put 6.12 in here. I could put 6.12 degrees in here. And I would get the right number. It just wouldn't be in miles, it would be in degrees. So then I'd have to multiply that by 60, and then I would have my miles, okay? So pretend, most of you pretend I just didn't say that, okay? All right, so I can put this in degrees, decimal degrees, and then do that computation, but I'm gonna have to multiply it by 60 at the end anyway. So I might as well just multiply it by 60 now. So this is gonna be so this equals 368 minutes. Okay, little l, equals 6 degrees 08 minutes, or times 60 plus 08, 368 minutes. Sorry about that, Gabrielle. Okay, so now we're almost done. 368 divided by the cosine, what am I going to stick in there? 43.5. And when I finish that, you should get 507.3. And that problem is now done. So, we're going to take a 5-minute break. Okay? You don't have to take it.